Dear friends, in previous lecture we seen the detailed syllabus of the 5th semester of chemistry. So we will directly move towards the first topic of first unit, that is the coordination compound first. The first coordination compound first is the first unit, and the first topic is the molecular or addition compound. So first of all we will see what is meant by molecular or addition compound. The definition of molecular or addition compound is that when the solution containing 2 or more salt in a stoichiometric proportion. When the solution containing 2 or more salt in a stoichiometric proportion are allowed to evaporate, we get the new crystal of the compound, and that new crystal of the compounds having the different shape than the parent compound is called as the molecular or addition compound. For example, KCl and MgCl2, these are the two salts. These two salts we are mixed together in an aqueous solution, and this aqueous solution is allowed to evaporate. Then we get the combined KCl MgCl2. This is the one of the compound, and that KCl MgCl2, this compound having the different shape, having the different crystal shape than the KCl and MgCl2. It means that the shape of KCl MgCl2 is different than the shape of KCl and the shape of the MgCl2. Hence, this type of compound is called as the molecular or addition compound. The next term is called as the double salt or the lattice compound. On the basis of behavior of the solution, or on the basis of the behavior in aqueous solution, the molecular or addition compound is classified into two types of compound. The first compound type is called as the double salt or lattice compound, and the second type is called as the coordination compound. The first type, double salt or the lattice compound. When double salt are the molecular or addition compound which exist only in a crystal lattice. Double salt are the molecular or addition compound which exist only in a crystal lattice but break down into their constituents compound when they are dissolved in water or any other solvent. Their properties or their chemical properties essentially remains the same as that of the parent salt. This type of salt is called as the double salt. I repeat here once again, double salt or the lattice compound are the molecular or addition compound which exist only in a lattice compound, which exist only in a lattice of the solid form, but break down into their constituents compound when they are dissolved in water or any other solvent, and their chemical property is completely same or essentially the same as that of the parent salt. This type of compound is called as the double salt. For example, Mohs salt, potash alum, and the carnallite. These three type of salt is the example of the double salt or the lattice compound. This, please see here, Mohs salt. Mohs salt is the combination of the ferrous sulfate and ammonium sulfate. Mohs salt is the combination of the ferrous sulfate and ammonium sulfate. When the ferrous sulfate and ammonium sulfate is mixed together, then there is formation of the Mohs salt. But the property of the Mohs salt is same as that of the ferrous sulfate and ammonium sulfate. We will see here FeSO4. Ferrous sulfate ionization of FeSO4 in aqueous solution, it gives the Fe dipositive ions and SO4 dinegative ions. Then we NH4 to SO4, ammonium sulfate or ammonium sulfate in aqueous solution, it gives the 2 NH4 positive plus SO4 dinegative ions. If we analyze this ferrous sulfate and ammonium sulfate, then we get this type of the ions. In these two type of ions, there is one ferrous, 2 SO4 1 and the second SO4, and 2 NH4 positive ions. If we ionize the FeSO4 whole Mohs salt, FeSO4 NH4 2SO4, then we get the FeSO4 dipositive plus 2SO4 dinegative plus 2NH4 positive. The comparison between, or the compare, here is the ionization of FeSO4 and ammonium sulfate. Then see here, one FeSO4, the one Fe dipositive or one Fe dipositive, same here. Then 2SO4, then 2SO4, one here is SO4, one another here is SO4. Then 2NH3, this 2NH3 is here is 2NH3. It means that Mohr's salt shows the similar property to the FeSO4 and the ammonium or NH4 to SO4. It means that double salt or the property of the parent compound or property of the parent compound is similar to the form of the compound, and this is the example of the double salt. Then B part, or the second part, is called as the coordination compound. Coordination compound are those molecular or addition compound which retain their identities even when dissolved in water or any other solvent, but their chemical properties are different than the parent salt, or chemical property are different than the parent salt. Coordination compound are the oppositely to the double salt, because parent compounds or compound which is formed shows the different property than the parent compound. Here the product form is shows the similar property than the to the parent compound. For example, in aqueous solution, our aqueous ammonia is added to the green solution of the nickel chloride. For example, in aqueous solution or the aqueous solution of ammonia is added to the green solution of the nickel chloride, then we get the purple color, or we get the purple colored NiNH3 compound, or NiNH3 compound Cl2 compound. If we ionize these two compounds, for example, Ni dipositive plus 2Cl negative, then in this compound, or 6NH3, it's not ionizes. Here this compound is ionizes, we get NiCN NH3 positive plus 2Cl negative. It means that there is no similarity in the compound formation, or there is no similarity. Here the Ni dipositive is present in a NiCl2, but in a coordination complex there is no free ions or free Ni ions produced in the NiNH3. Hence it shows the different property than the parent compound. This type of compound is called as the coordination compound, or this type of compound is called as the coordination compound. The next topic is some terms which is involved in the coordination compound, or some terms which are generally used in the coordination compound, which is also seen here. The first term is called as the central metal atom. Then second term is called as the ligand. Then third term is called as the coordination number, and all these we are seeing here one by one. General terms which are used in a coordination compound. The first term, what is meant by central metal atom? Central metal ion. In short, it is called as the CMI. So what is the definition of the CMI? First of all, we will see the central metal ion, or what is meant by CMI. CMI means it is the positive metal ion. It is the positive metal ion or cation which is attached by the two or more electron. It is the central metal atoms. What is the central metal atoms? First of all, central metal atom means it is the positively charged cation. It is the positively charged cation. Positively charged ion or cation, positively charged cation, which has attached to two or more neutral or negative molecules, or sometimes or rarely the positive molecules attached to the CMI is called as the central metal atoms. Once again, I repeat here, it is the positively charged metal ion which is attached to the two or more negatively or sometimes positively charged, sometimes positively negatively or sometimes negatively neutral or sometimes positively charged in a coordination complex. This type of ions is called as the central metal ion. For example, I take here one example here. AgCN2, one negative charge. In this complex, AgCN2, one negative charge. In this complex, Ag is called as the CMI. Ag is called as the CMI because Ag is having a positive charge. Ag is having a positive charge, and Cn is a two ligands which is attached to the central metal atoms. Hence, it is called as the central metal atoms. Central metal atom is Ag because Ag is a positive charge and two Cn ligand which is attached to the Ag. Then next term is called as the ligand. The group attached to the CMI, the group attached to the central metal atom is called as the ligand. The group attached to the central metal atom is called as the ligand. The ligand may be neutral, positive or the negative. For example, neutral ligand is H2O, then NH3, then negative ligand is the OH, Cl, F ligand. These are the examples of the ligand. The ligand means the group attached to the CMI. The group attached to the CMI is called as ligand. For example, H2O, NH2, OH negative, Cl negative or F negative. In a coordination sphere, I take one other example, CO, NH3, 6 tripositive. This is the coordination complex. This is the coordination complex. CO, NH3, 6 tripositive complex. In this complex, CO or cobalt, this is the cobalt. Cobalt is called as the central metal atom. Why it is called as central metal atoms? Because 6 ammonia molecule is attached to the cobalt. Hence it is called as the CO or it is called as the central metal atoms. Then according to the definition of ligand, the group which is attached to the CMI is the cobalt. Then group 6 ammonia molecule is attached to the cobalt. Hence, this group or this ammonia molecule is called as the ligand. This group or this molecule is called as the ligand. I take another example, AgCN2, negative charge. In this, cyanide molecule is attached to the Ag molecule because Ag is a CMI and Cn is attached to the Ag. Hence, this Cn is called as the ligand. The groups attached to the CMI is called as the ligand. Then third, coordination number. What is meant by coordination number? The coordination number means the total number of coordinate bond. Third terms, coordination number. Coordination number. Or it is, in short, it is called as the Cn. Coordination number means the total number of coordinate bond that can form by the CMI. Means how many number of CMI, central metal atoms, can form the coordinate bond. This type of bonding or this type of number is called as the coordination number of that coordination complex or that compound. The total number of coordinate bond can be formed by the CMI in the coordination compound is called as the coordination number. For example, CO NH3 tripositive complex. CO NH3 tripositive complex. In this complex, CO is called as the CMI because CO is a positive metal atom, according to the definition of the central metal atoms, CO is a CMI, or it is called as the central metal atoms. The number of group attached to the CMI is called as the ligand. Then 6 ammonia molecule is attached to the ligand. Then ammonia molecule is called as the ligand. And number of bond. See here, CO forms the 6 bond with the 6 NH3 molecule. CO forms the 6 bond with the 6 NH3 molecule, or the 6 molecule of ammonia is attached to the CO. Hence, the coordination number of this complex is a 6, and this number is called as the coordination number. This number is called as the coordination number. I take another example. Mn NH3 dipositive. Mg NH3 dipositive. In this, Mg is CMI. NH3 is called as the ammonia molecule is called as the ligand. And this 4 quantity or 4 ammonia group attached to the Mg, that central metal atoms. This 4 number is called as the coordination number. This 4 number is called as the coordination number. It means that the total number of bond that can be formed by the, or total number of coordinate bond that can be formed by the cobalt or the central metal atoms, then it is called as the coordination number. Then next term is called as the complex ion. What is the complex ion? The complex ions means complex ion. The complex ion, an electrically charged radical. Complex ions means an electrically charged radicals containing central metal atoms and 2 or more ligand in a coordination compound is called as the complex ion. What is the definition of complex ion? An electrically charged radical. An electrically charged radical containing CMI and 2 or more ligands in a coordination complex is called as the complex ion. It means that, for example, in a coordination sphere COCN6, the next example COCN6 dinegative. In this example, complex ions means an electrically charged radical ions and electrically charged radicals containing CMI and ligand, 2 or more ligand. This type of compound or this type of combination of ions is called as the complex ion. The complex ion consists of one of the central metal atoms and another is the ligand. This group combination is called as the complex ion. The third or next definition, complex compound. The fifth definition is called as the complex compound. Complex compound. What is meant by complex compound? The compound in which complex ion is present, that type of compound is called as the complex compound. Very simple. The compound in which the complex ion is present, those compound in which the complex ion is present, that type of compound is called as the complex compound. For example, CO NH36 tripositive. CO NH36 tripositive. In this complex compound, here is the COS CMI. The NH3 is called as the ligand, and tripositive is the charge of the coordination complexes. It means that in complex compound, complex ions is present. Complex ion or central metal atom and ligand is present. This type of compound is called as the complex compound. The next last definition of the coordination pair. Coordination sphere. What is meant by coordination pair? The coordination sphere, it means that, or in a coordination compound, in a coordination compound, the central metal atoms is directly attached to the ligand. In a coordination compound, the central metal atom is directly attached to the ligand. In a coordination compound, then it is said to be the coordination pair. In a coordination compound, the central metal atom is directly attached to the ligand. It's said to be the coordination pair. For example, NH3 4 dipositive. In this example, coordination pair Ni is central metal atom. Central metal atoms is directly attached to the ligand. In a coordination pair, this is called as the coordination pair. In a coordination pair or in a coordination compound, then this type of compound or this type of arrangement of atom is called as the coordination pair. Coordination pairs means in a coordination compound, the central metal atoms is directly bonded or directly attached to the ammonia molecules or the ligand molecules. In a coordination pair, this type is called as the coordination pair or coordination molecule. Then we will move towards the next topic of our unit first, that is Werners theory. Werners theory of the coordination compound. Werners theory of coordination compound. The next topic, Werners theory of coordination. Werners theory of coordination compound. In 1893, the Werners put forward a theory. In 1893, the Werners put forward a theory which is related to the structure and formation of the coordination compound. In this type, or the Werners put forward a theory which is related to the formation and the structure of the, and due to this work or due to this recognition of this work, he got the Nobel Prize in chemistry, and rightly it is called as the father of modern coordination chemistry. Father of modern coordination chemistry, Alfred Werner. Alfred Werner is a scientist, was a scientist, and he proposed or he put forward a theory, which is related to the formation and the structure of the coordination compound, how the coordination compound is formed, and what is the bonding of that coordination compound, which is related to, and due to this work, he got a Nobel Prize, and now, or rightly, it is called as, or Alfred Werner is called as the father of modern coordination chemistry. So we will see what is the postulates of that Werners theory. Postulates of Werners theory. So first postulate is that in a coordination compound, most of the elements show the two type of the valency. In the first postulates of the Werners theory, in a coordination compound, most of the elements show the two types of valency. The first valency, or the first is called as the primary valency. The first is called as the primary valency, and the second is called as the secondary valency. The first called as the primary valency, and the second is called as the secondary valency. This is the first postulates of the Werners theory. What is the first postulates of the Werners theory? In a coordination compound, most of the elements show the two types of valency, that is the primary valency and the secondary valency. The second postulates, the primary valency is ionizable. The primary valency is ionizable, and it is satisfied by the negative molecule. it is satisfied by the negative ligand or the negative molecule, and it is also called as the oxidation state of the metal atom, or it is also called as the oxidation state of metal ion or metal atoms. This is the second postulate of the Werners theory. What is the second postulate? The primary valency is ionizable valency, and it is satisfied by the negative ions, and generally, or it is called as the oxidation state of the metal atom. First postulate is that in a coordination compound, most of the metal atom or the most of the elements show the two types of valency. First is the primary valency and second is the secondary valency. This is the first postulate. Then second postulate, the primary valency is ionizable. Primary valency is ionizable, and it is satisfied by the negative ions or the molecules, and generally the primary valency is called as the oxidation state of the metal atoms. The third postulates the secondary valency. The secondary valency is non-ionizable valency. The secondary valency is non-ionizable valency, and this secondary valency is called as the coordination number of metal atom. The secondary valency is called as the coordination number of the metal atom.